Hello, welcome to this lesson of our study of partial differential equation. Alright, so in this video, I will take you through how to solve an equation of this form. Okay, it's non-homogeneous though, but then the coefficients of ux and uy are both variables. Okay. Alright, so quickly let's start. In our study of PD, we said that whenever you have an equation like this, you just solve this characteristic equation, and this is equal to dy dx is equal to what? The b, the component here, okay, in front of ui, the component in front of ui, this one, over the component in front of what? Ux. So I have minus y over x, and this means I have dy over y should be equal to negative dx over x. Okay, now with this, I'll have ln of y equals minus ln of x plus c. So I have ln y plus ln x equals c. So this would actually give me ln of xy in logarithm, okay, is equal to some constants s or c. Let me put it that way. Okay, let me put it to be c. Okay, now I have xy should be equal to e to the power c, and e to the power any number. C is a constant, so e to the power any number is still a constant. So I say xy should be equal to s, and this means that this will be an equation that will characterize the PD given. Okay, now once I have this, there's no a plus b and whatever for me to change the coordinates. Okay, so one thing that you can do is that you can choose an arbitrary function that will also characterize this PD, and we just don't choose it. Okay, you choose tau equals x, always this will work. But then the idea is that you have to choose a function that the Jacobian, okay, of both s and tau, the Jacobian of both x and tau will always not be equal to 0. Okay, and indeed if you check the Jacobian, it will never be equal to 0. Okay, so this is the idea behind it. Now I have my s, I have my tau. So one thing I have to also go and do is find my ux and my u tau, or sorry, my ui, all in terms of what? Tau and s. But here, let me quickly find expressions for x and tau. Although we are saying tau is equal to x, it means that the transformation for x is that s is also equal to tau, and y is also equal to what? S over x, which means that my y is actually equal to s over what? Tau. So let's keep these in mind. Okay, alright, then let's quickly go ahead and find our ux and our u tau, sorry, ui. Okay, my ux, okay, my ux here, ux is equal to du ds times ds d tau, sorry, dx, plus du d tau times d tau dx, and now this will give me what? Du ds dx is what? So you come back and check. Ds dx is y, okay, and d tau dx is what? 1. Okay, so I have y us plus u tau, and my ui would actually be equal to d what? Du ds times ds dy plus du d tau times d tau dy, and now this will also give me ds dy is actually x, okay, then us, and d tau dy is 0 since tau does not depend on y. Okay, so I have that. This is my ux, this is my ui. Okay, so let's keep this in mind. I'm coming to write them at the top here so that we simplify our PD in terms of them. Okay, Alright, after simplification, then this will be very, very simple for us to solve. So I have my ux being equal to y us plus u tau, and my uy being equal to x us. So I come back, my differential equation or my PDE is actually this. So I write it back. Okay, let me go and write it back. So I have x okay, minus y uy plus y squared u equals some y squared. So what I do is I know x is equal to tau and y is equal to s over tau. So I just substitute them back in the equation. I have x and us is what? Yus plus u tau, then minus y uy is what? Xus, and plus s over tau all squared u. This is equal to s over tau all squared. Okay, now I have xy. The reason why I'm not transforming them back right now is that this side there might be some cancellations there. Okay, and minus xy us, okay, and plus s squared over tau squared u equals s squared over tau squared. Okay, now this can take this off, so I'll be left with x, and x is what? Tau. Okay, so I have tau u tau plus s squared over tau squared, okay, over tau squared u, and this should be equal to s squared over tau squared. So this becomes our new ODE that we have to solve. Okay, this is a more simpler way for us to solve this. Okay, now let's go ahead and write it. Tau u tau plus s squared over tau squared. So I have our ODE is tau u tau. Okay, let me write it to u tau plus s squared over tau squared u, and this is equal to s squared over tau squared. Now to solve this, we said you have to separate this into homogeneous and non-homogeneous. Okay, so the homogeneous part is this: tau u tau plus s squared s squared tau over u. This is equal to 0. This is homogeneous part. I solve this and I'm done for the homogeneous. Okay, so I have if I divide through by tau, I'll get u tau plus s squared over tau cube. Okay, s squared over tau cube u should be equal to 0. And now my integrating factor if is equal to e to the integral of s squared over tau cube, which is the same as s squared tau to the power negative 3, then d tau, and this will give me e to the negative, okay, 1 over 2, then s squared over tau squared. Okay, so this is very simple. This is it. I just have to come and multiply it through this ODE, this side, okay, and solve it. Okay, so if I multiply it through, this is what I have. If I multiply it through and then I want to solve quickly, this is what we will write: d tau. We've been doing this or since, so you can watch our previous video and see why you are writing this. Then u e to the negative 1 over 2, okay, negative 1 over 2 s squared over tau squared, okay, s squared over tau squared is equal to 0. Now this will be the integral of both sides, okay, but actually the left side will be d. Let me write it so that you get it more. Okay, 1 over 2 s squared over tau squared, okay, then it's equal to 0 d tau. Instead you have u e to the negative 1 over 2, okay, s squared over tau squared, okay, should be equal to some constant. This constant should be in terms of s, because u depends on both s and tau, okay. So now I quickly clean this part, okay, and write the solution in a simple way, okay. Now I have my homogeneous solution. The u homogeneous is actually equal to, now I divide through by this negative 1 e to the power negative half s squared over tau squared, and I'll get e to the half s squared over tau squared, okay, and times f of s. This is my homogeneous solution. Very, very simple. Very simple like that. So I have to come back and write the solution for a particular solution, okay. Now we said that the particular solution will depend on the equation or the polynomial or whatever function that is at the right side of the equation, okay. Now I have tau u tau plus s squared, okay, s squared u over tau squared is equal to s squared over tau squared. This is the ODE we are solving, okay. Now if I divide through by tau, I'll get u tau plus s squared, okay, let me write it all for you, s squared over tau cube, then u should be equal to s squared over tau cube, okay. So this is it. Let's go and then solve and write a polynomial function for a particular solution, okay. So I have u tau plus s squared over tau cube, u should be equal to s squared over tau cube, okay. Now this is in a linear form. This is something like this: s squared tau to the negative 3 u plus s squared tau to the negative 3. Now you can see that the order of this polynomial is what, 3, although it's a negative 3, but it's 3, okay. So the particular solution we can write is up. We let a particular solution be equal to up is equal to some constant a times tau to the negative 3 plus some constant b times tau to the negative 2 plus some constant c tau to the negative 1 plus some constant d that we don't know, okay. So this is our particular solution, and then the differential of this particular solution with respect to tau is given as negative 3a tau to the negative 4, okay, plus negative, so let me just use the negative straight away, minus 2b tau to the negative 3 minus c tau to the negative 2, then plus 0, okay. So all that I do is I come and put this u tau and up in place of in this equation, okay, this equation. So wherever I see u tau, I put u tau there. Whenever I see u, I put up, because that is my solution I'm suggesting to this equation. Alright, so if I put u tau there and this, I'll get something like negative 3a tau to the negative 4, then minus 2b, let me write it all, tau to the negative 3, and I have minus c tau to the negative 2, and plus s squared tau to the negative 3 multiplying u, and u is giving us a tau to the negative 3 plus b tau to the negative 2 plus c tau to the negative 1 plus d, all should be equal to s squared tau to the negative 3. Okay, so we simplify this expression and we compare coefficients. Okay, so let's push this upward like that. Okay, now let's try to simplify this. If I simplify this, I'll get negative 3 a tau negative 4 minus 2b tau negative 3 minus c tau negative 2 plus, then I multiply s squared tau to the negative 3 throughout this. Now I'll get a s squared tau to the negative 6 for the first one plus b s squared tau to the negative 5 plus c s squared tau to the negative 4 plus d s squared tau to the negative 3. Okay, tau to the negative 3. Then all of this will be equal to s squared tau to the negative 3. Okay, now you have to add powers to group powers to one side. Okay, so if I group the powers, I'll get something like, in terms of, let me start from the highest. Okay, in terms of negative 6, I have a s squared tau to the negative 6, then plus, when it comes to negative 5, I don't have negative 5 anywhere except b s squared tau to the negative 5. Then with the negative 4, I have two of them. I have this part and this part, so I have to add them. Plus, okay, plus c s squared minus 3a tau to the negative 4. Okay, then I go to the negative 3 plus d s squared. Okay, d s squared minus 2b, okay, tau to the negative 3. Alright, and minus c tau to the negative 2. All should be equal to s squared tau to the negative 3. So I pick my polynomial at the left side and compare coefficient to the right side. Okay, now you can see that the coefficient of this polynomial, okay, the degree of the polynomial, let's say degree to the power negative 6 or the tau to the negative 6 at the right side of our equation is 0, because we don't have any power like negative 6 at this side, so it means that the coefficient there is 0. So it means as squared equals 0, and this will imply that my a is actually equal to 0. Okay, and with the tau to the negative 5, I have bs squared equals 0. That one, so you don't have any other coefficient there, so it means b is also 0. Then with the tau to the negative 4, I have c s squared minus 3a equals 0. We don't have any tau to the negative 4 in the right side, but since a is 0, this implies that I have c s squared equals 0, and this also implies that c is equal to 0. Now with the tau to the negative 3, I have d s squared minus 2b should be equal to the coefficient to the tau to the negative 3 is s squared here, so I have s squared, but b is 0, so this implies that I have d s squared equals s squared, and s square will cancel, s squared, and d will be equal to what? 1. Then I come down here for my, I think that is what we are finding a, b, c, d. Okay, my c is being, I found c. Okay, we found c. A is known, b is known, c is known, and d is also known. Those are the things that we want to know. Okay, so once we know that a is 0, b is 0, c is 0, and d is 1, I just go back to where I wrote the particular solution, that I should let my u particular, or the solution of this function, be equal to that. So this is a u particular. You said this is a solution that we are suggesting. Okay, but a is 0, b is 0, c is 0, only d is what? 1. So it means that my u particular, or the particular solution here, is putting them back in, and I'll get d to be what? 1. So I have 1. So the solution to this whole problem, is u of s tau should be equal to u homogeneous plus u particular, and this is equal to u homogeneous. We have something like e to the negative 1 over, sorry, it was positive rather, 1 over 2 s squared over tau squared, then f of s plus the u particular, we had 1. Okay, now this is in terms of s and tau, so u of xy will be what? Now we said that y is equal to s squared over tau squared. Okay, no, sorry, y squared rather. Okay, so actually y is equal to s over y tau, s over tau, and so y squared will be s squared over tau squared. So I have e to the half, then y squared, f of s was xy, and plus 1. This f is multiplying that, so that is my solution. The solution to this is very simple: e to the y squared over 2, then f of xy plus 1. This is a solution to this problem, the problem that we were solving. Alright, so thank you, and I believe that any form of first order ODE that will be given to you, either homogeneous or non-homogeneous, after passing through these lessons, you'll be able to solve. In our next discussion, go to the transport equation and know how to solve that question as well, or that problem. Okay, thank you, and don't forget to subscribe to my channel if you have not subscribed.